Welcome back. I want to improve this function just a little bit. You see, ideally, we don't want to fill the cache in what we call the global scope. That is, to be living outside of this function. Ideally, it's good practice to have memory, or in this case, the cache, to live inside of this function, not polluting the global scope. And there's many ways to do this based on the language. In JavaScript, we can use something called closures. And this is what it would look like. And I'm showing you this because when we get to dynamic programming, you're going to see this pattern a lot. Luckily, with dynamic programming, the pattern is usually always the same. So once you learn this, then it becomes easier and easier. So the way we bring this inside of the function is to, well, bring it in like that. But the problem is now that every time we run this, we get long time each time because the cache gets reset every time the function gets called. So the cache becomes an empty object. To get around this, we can use closures in JavaScript. And we can return another function, so a function that returns another function. And in here, we'll pass the parameter n. And we'll have the logic inside of this function. That's it. And because of something called closure, we're able to access this cache inside of this child function. Now, this isn't a course about JavaScript, so you can read up on closure on your own. But this is just a way for us to avoid that global scope. So that this time around, we can do something like this. We can simply say const memoized equals memoized add to 80, and we'll run this function. And we can actually even remove the parameter from here so that we have flexibility. Let me show you. We have the memoized here, which hopefully I can spell, memoized, so that now this function, because I ran it, is going to return for me this function. Memoized equals this function. That's literally what memoized add to 80 returns. And I have access to this cache variable. So that in here, I can just say memoized 5 and memoized 6. If I hit run, I still get the same thing. But if I do 5 and 5 and I hit run, look at that. It's memoized. This function remembers that the parameter has not changed. It's the same parameter, and it's going to check the cache and say, I don't need to do all that silly calculation. I already have it. Here you go, just using a hash table. Here it is. And what we just learned here is really powerful because it allows us to be very efficient with our code, something that we know interviewers love, companies love. And dynamic programming allows us to use what we know now about memoization to optimize our code. Let's find out more in the next video.